So as you can see, not only my fingers are being counted right now, but each separate finger is being individually recognized. And this allows me to create a variety of hand gesture recognition based applications. So for example, I can create this, an image filter that turns on when I do this Spider-Man hand sign, and it turns off when I do this high five hand sign. So turn on and turn off. And there's another thing, I can do this victory sign and it will take an image. So let's turn on the filter and now take another image. So this is what we'll be building in this tutorial. This is a 3-in-1 tutorial. A hand finger counter, a hand finger recognition system, and a hand gesture recognition system. I hope you're just as excited as me, and let's get started. So I'll be following along this Jupyter notebook for today's tutorial. You can download it from the link in the description below. So I'm assuming that you have already watched my previous tutorial on hand landmark detection, where I teached how to do real-time hand landmark detection and some other things. Even if you haven't watched it, I'll briefly revise it in this tutorial. So let's get started. So I'll start by importing the required libraries. As usual, we'll be working with OpenCV, Mediapipe, Matplotlib, NumPy, and I'll today also be importing this Pygame library, and the only thing I'll be doing with this is just playing a particular sound in the final application. So even if you don't want to install and import this, it's totally fine. So I'm going to import it right now. So we're all set now. So now I'm going to initialize the hand landmark detection class and its function. So this will allow us to use the hand landmark detection. I've already covered in detail what each of the variables in these functions mean in the previous tutorial, so you can look at that. So here I'm initializing the hands class for the Mediapipe hand landmark detection, and here I'm setting up the required variables and initializing the function to do the actual landmark detection. And then here I'm initializing the drawing class, which will help me to draw or annotate the hands in real time. So once that's done, all I'm going to do is create a function that will output a hand skeleton and do the real-time hand landmark detection. And inside this function, I am reading the image, I'm converting the image in BGR, and then I'm processing it. So here's where all the processing is happening. All you need to do is pass in an image in RGB format, and this function will take care of all the processing, and it will give you this results object, and then you can extract from this object the hand landmarks. Right now I'm just interested in drawing the hand landmarks, and obviously I have this condition here which makes sure that the hands are detected. Otherwise there's no point in drawing a hand on the screen if there's no hand there. And once that is done, I'm going to display the results, or I'm going to return the results if we're working with videos. So this is how this whole function works. And just to revise, these are the hand landmark points that we're going to draw. As I've said, I've gone in detail regarding all of these things in the previous tutorial. So make sure to check up on that after you're done with this one. Okay, so once I'm done initializing this hand landmark detection function, I'm going to check it on an image. So this is a sample image. I'm using OpenCV to read an image, and then I'm calling this detect hand landmarks function to detect the hand and display the results. So this is how this looks like. So this is the original image, and once I've detected and draw the hands, this is how the result looks like. So in this step, we're going to count the number of fingers that are raised by the hand, and we're going to do this for the right hand and the left hand, both simultaneously. And so this is how this will look like. So if you do this, the hand will be detected, but it will count as 0. So this is 1, 2, 3, 4, 5. And obviously this is also 3, and this is also 3, and you can do this. This is also 3. So this is how this will work. So these are all the coordinates that Mediapipe gives you. So what you will do is store up the tip points of each of the fingers. So for index point, we have this tip point, and for the middle finger, we have this tip point. And then what we're going to do for each tip point of the finger, we're going to compare it with its middle point. So we're going to compare the y coordinate. So remember, the y coordinate is 0 at here, and it goes up at the bottom, right? It increases towards the bottom. So we're going to compare the y coordinate value of these landmark points, and we're going to see if this tip point is above this middle point, then we're going to assume that index finger is up. Otherwise, we're going to assume the index finger is down. So this is how this is going to work. This is up and this is down. If the finger is down, then the index point will be below the midpoint. So this is the whole intuition behind this. As you can see, the finger is up here and the finger is down when you're closing the hands like this. And this is all fine for the 4 fingers, and this is going to work fine for the right hand and for the left hand. But when we're talking about the thumb, there are going to be a couple of problems. So when you're raising your hand like this, the thumb goes like something like this, and because of this you can't just calculate the y coordinate and compare it with the midpoint, because there's going to be lot of fluctuation, and it's not going to give you the best results, because the thumb is like this, right? So we're going to apply a different strategy for that. We're going to compare the x coordinate for the thumb. So for the thumb, what we're going to do is check if the thumb is closer to the, has a lower x-axis value, and this midpoint has a higher x-axis value. Only then we're going to consider the thumb is open. Otherwise, if that is not the case, if I close the thumb like this, then this value will have a higher x value coordinate. If we're assuming that the x-axis starts from here, the x-axis is 0 at the corner here and goes towards the maximum value towards the right. So for this particular hand scenario, this is how this is going to work. And similarly, this is true, for example, this is true for the right hand, but for the left hand, the scenario is going to be different. If I put up both of my hands, then this whole scenario is going to be flipped up. So for the right hand, this value should be, the strict value of my thumb should be less than this midpoint, and it's going to be vice versa for this hand. So because the thumb is pointing towards this direction, and for the right hand, it's pointing towards this direction. So this is why we're going to just flip the condition. But it's going to work either way. But there's a constraint that I'm introducing because of this logic, and this is the constraint here. Let me show you. So the whole detection and the counting is going to be done perfectly fine when you counting the hands like this. But if you do something like this, then it's going to collapse. So if you do something like this, then because of this same logic which I just described, this is going to count as 8. But again, you can fix this up. You can easily fix this up by introducing more conditions. But because I wanted to keep this whole script pretty simple, I'm not gonna introduce a lot more conditions to handle this particular scenarios. I'm gonna assume that everyone is gonna hold up their hands like this, not this. Anyways, let's move on. So here's the code that's doing the whole finger counting and finger recognition. So first up, I'm gonna read the image and make a copy of it, and then I'm gonna make a dictionary which is gonna hold the total number of fingers in the right hand. So initially it's gonna be 0, and for the left hand it's also gonna be 0. So if both my hands are up like this, then both of these dictionary will have 5 here and 5 here. So if my left hand has 5 fingers up, this will be 5 and this will be 5 at the end of this script. So this is the dictionary for that, and this is the list which will hold all the tips, fingertips. So I'm only storing the index, the middle finger and the ring finger and the pinky finger tip. So I'm not storing the thumb tip because there is a different logic for that, as we've just talked about. So these are the finger tips IDs. So these are the indexes of the fingertips. And I have now another dictionary here which is going to store the status of each finger. So for each of the 10 fingers, I have a status. So if the finger is down, then the status is false. If the finger is up, then the status is true. So if I only do this, then the status of my right hand's index finger will be true, and all the rest of the fingers should be false. So this is how not only am I counting the total number of fingers, but I'm also storing the status of each individual finger. Alright, so now I'm going to iterate over both hands. Then I'm going to retrieve the label of the hand. So either is it a left hand or is it a right hand. So this is the label. And then I'm going to retrieve the hand landmarks for that particular hand. And then I'm going to iterate over all the fingertips IDs, and I'm going to extract the finger name. So I'm going to split it by the underscore. As you remember here, the finger names can be, you can extract the finger name by splitting with this underscore. With the first underscore, you can get the middle, ring or thumbs, any finger tip name. So that's what I'm doing here. And then what I'm going to do is check. And this is where the main thing is happening. So in this line, I'm checking to make sure if the tip of that finger is above the midpoint. So this is where this condition is being handled. So if the y-axis is less, the tip of the y-axis is less than the tip of the mid, then it's considered that the finger is up like this. And if that is the case, then I'm going to change the status of that particular finger to true. And I'm going to also increment the counter variable by 1. So that means that another finger is up, so +1. So this is going to be done for all of the 4 fingers for both hands. Now the thumbs are left. And this is where I'm handling the thumbs part. So for the thumbs, I'm gonna first extract out the thumbs tip and the thumbs midpoint by doing in these two lines, and then I'm gonna check two sorts of conditions. So if the hand label is right, then I'm gonna check to make sure if this thumb tip is less than the thumb midpoint. Otherwise, if the hand label is left, then I'm gonna check the vice versa. And for both of these, I'm gonna set thumb to true for that particular hand, and then I'm also gonna increment 1 to the hand label. Anyways, so once that is done, we're gonna draw out the final results, and we're gonna display the image or return the results if you're working with videos. So this is how this whole function works. Let's run this, and now we're gonna test it up on a video. So let's check it out. So these are the results. As you can see here, both of my hands are detected and the total counter is being displayed on top here. If I do something like this, 2 fingers down, it said another finger 7, another finger 6, and if I move a thumb here, 5, 6. And similarly, I can count the total number of fingers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, this is working pretty fine. As you can see, the problem with this one, this is 8 and this is 10. Alright, so this is cool and all, but how about instead of just displaying the total count, we also visualize and display the actual fingers that are up, and this will be a lot more cool than just displaying the total number of fingers. So in the next step, we're going to do that. So in this step, we're going to visualize the actual fingers that are being raised. So this is how this is going to look like. So let me show you an example for that. So here's how this will look like. So if you have 1, 2, 3 or 4 or 5, any number of fingers, this will show you exactly how many fingers and which fingers are up. So, and this will work for both of the hands, and it's pretty cool. Alright, so for that what we need is just a number of images like this. So we have images stored up on our disk like this, and these are the images. So as you can see, these are all the images that I have, and depending upon which fingers are raised and which fingers are down, I'm gonna show individual images, overlay individual images on top of the screen. And these are, by the way, these are PNG transparent images. So they have an alpha channel, and I'll get into a bit what the alpha channel is. Also, I've carefully named all of these images, so the code works perfectly fine. Also, I've very carefully named all of these images. So now let's go over the code. So this is the code here. I'm going to start by extracting the height and width of the original image, and then I'm going to first load up the paths in a dictionary of both hands. So initially I'm going to load up these two images. So left hand not detected and right hand not detected. So initially this will be the status when no hands are detected. Later on, if any of the hands are detected, I'm going to update the paths here. So initially we will have a dictionary called hands images paths, and it's going to have two keys, left, right, and the value of both of these keys will be the path of the image. And initially these images will be the red ones. So now if the hands are detected, if any of the hands are detected, then we're going to update this dictionary value. So we're going to update the hand, the detected hand, with another image called hand detected.png. So this is what I'm gonna be replacing it with. Left hand detected or right hand detected. So this is gonna be the red image is gonna be replaced by this green image if any of the hand is detected. And depending upon which hand is detected, so that particular image will be replaced here. So this is what's happening here. As you can see, I'm actually extracting the label here. So I'm extracting left or right. I'm doing hand info.classification 0 label. This is going to give me left or right depending upon which particular hand is detected. If both are detected, then in the first iteration I might have left or right, and in the second one I have the other one. So this way I'll cover both of these, update both of the hand images. So now that once that is done, I'm going to count the total number of images. And if the total number of images is 5, and then I'm going to again update the image path with all fingers.png image. And this is the image for that. So where is it? Yeah. So this is the image. Left all fingers, I'll have this image, and for the right all fingers, I'll have this image. So if no hands are detected, then we'll have this red image. If the hands are detected, but there's no fingers over there, then these images will be detected. If the hands are detected, but all the fingers are up like this, then these two images will be overlaid. So right now I'm not overlaying the image actually, I'm just updating the image paths. The overlaying section is here. So I'm going to go over that. But this is the part where we just setting up the actual images to be overlaid depending upon what hand or which hand or how many fingers are like up at the moment. So anyways, this is the scenario for if all the 5 fingers are up. But what if some individual fingers are up, not all the fingers? So this is the case for that. So if individual fingers are up, for example, I'm going to iterate over each particular finger, and then I'm going to check if the status of that finger is true. Remember, I'm calling this function annotate, and I'm going to pass in the results, and I'm also going to pass in the finger statuses. So this is the dictionary which previously hold the false and true status for each of the fingers. So before running this particular function called annotate, which is going to display the results, I'm going to pass in the finger statuses. So this function will know which finger is actually up. So now I'm going to check if the status for that particular finger which I'm iterating over is true, along with the required hand. So is it a left or right? And depending upon both of these things, I'm going to append a path. So I'm going to append, if that, suppose if index finger is up, so I'm going to append this the path of this finger. So if the index of my right finger is up, then I'm going to append the path for this particular image in this particular list. So sorry, this list. So here what we are having, we have 2 lists, and we only have a single item here, and that item is the path for the red images. And as soon as we start to detect new fingers, so if I detect 2 of these fingers for my right hand, then I'm going to add 2 paths here. So I'm going to add this right index path for this image, and then I'm going to add the right middle finger path for this image. Right now I'm just adding the paths. Later on I'm going to load up the images from these paths and display over the actual image. So all the logic that is here is making sure that as soon as new fingers are detected, we add more and more paths to the initial list. So initially, like I said, we only have 1 path. So this list has a single item, and as soon as we start to detect multiple fingers, we're gonna, for each finger, we're gonna check if that finger is up, and if it is, we're gonna add the path for that particular image to this list. And we have orange images. We have the images have orange color if the finger is up. Otherwise, you're gonna see this green here, and red if no hand is detected. So this is how the whole thing is structured. Anyways, once we're done adding the paths based on which image is or which hand is displayed on the screen, then later on what we're going to do is actually display those hands on the screen. So this is the code for that. Now let me explain this piece of code with a nice illustration. So I've opened the Microsoft Paint here to explain more in detail what's happening in this particular piece of code. So we're going to start off by iterating over the dictionary of the hands. So initially we have this dictionary that have 2 lists, left and right. So this loop is going to run 2 times, one for the left hand and one for the right hand. So once we've done that, then we're going to iterate over each of the paths. So as you can see here, we have previously what we did was we store up a number of paths depending upon how many fingers and which fingers are up. And depending on those fingers, those particular paths of those particular fingers were stored on the left and right list, which is inside this dictionary. And now what we're doing here is iterating over each path. So remember I told you that we're loading up the paths right now, but later on we're going to read up the actual images. So this is what we're doing here. We're reading up the actual images. So for each hand, and this is actually a hand which I drew with my excellent drawing skills. Anyways, so this is the hand. As you can see, this is a normal colored image of a hand. Again, like I said, this is the best I could draw at the moment. Anyways, so what we're doing here is I'm reading up an image, and here what I'm doing is I'm passing this particular flag. So cv2.imread unchanged, and the reason for that is by default OpenCV reads an image in color, but I don't want to read the image with normal color. I want the image to read as it is, because what I have in my disk is PNG images, transparent images, and transparent images actually have 4 channels. So we have the normal RGB or the BGR color channels, which is blue, green and red channels, and there's another channel called the alpha channel, and this is the channel that stores the transparency of the image. So if you have something like this, then this tells you that the white part of the image is shown and the black part here is hidden. So any image that you display over any other image, the black part is replaced by that background and the white part of the image will take on the original part of the image. So this is the information that the alpha channel holds. It's normally a black and white image, but it can have some gray areas. So if you have a gray area, then 50% of the background will be shown and 50% of the original part of the image will be shown. Something like this. But in this scenario, you can consider this alpha channel as simply a black and white image, where the white part is the actual part that you need to show and the black part is this. So remember when I showed you this example here. So this is actually a transparent image. So as you can see, this is the part of the actual image and the background is taken up, the background of this image is the same as the background of this particular video. And this happens because we're working with transparent images. This is the only way you can do that. Otherwise, you will have a squared white box or any particular background will be displayed on top of the image. And so for that to happen, what you need is to load the image in the alpha channel of the image. So we have an image which has 4 channels. Now we're going to separate the alpha channel by doing this, and we're going to separate the BGR, the color channel, by doing this. So here we are extracting the alpha channel is the last channel, so we're extracting the alpha channel and separating it, and we're extracting the BGR channel and separating it. And then we're also getting the height and the width of the actual image. So and we're doing that because we need to overlay it on the image. And for that to happen, we need to extract an ROI from the image, which we need to modify and then replace it. So here's what I'm doing here. So we extract the height and width of this image, and using the height and width, we extract a piece of an ROI from the original image. So this is the original video feed. So this is where I need to overlay the image. So what I do is extract the height and width from here. And then after I get the height and width, I understand which particular area I need to modify. So I extract an area from the original image using that same height and width. And this is what's approximately happening here. So let me show you the whole code for this. So this is the whole code here. So what I'm doing is I'm just starting the Y value from here. So I'm giving a 30 padding here. So I'm starting the Y from here, and for the width where I'm starting is that 1/12 of the image. So 1/12 might be here or might be here, something like that. So 1/12 of the image is where my starting point is, and the 30 pixels here is my Y axis starting point. So this is the corner where I'm starting the cropping, and the total area depends upon the actual height and width of the image which I'm replacing it with. So once I've done that, once I've gotten the ROI, the next step is to modify that ROI. So what I'm going to do is I'm going to take this ROI piece. Once I've extracted it, I will have something like this, and then I'm going to use the alpha channel. I'm going to use the alpha channel and understand where the white part of the image is. And wherever the white part of the image is, I'm going to overlay the original image on top of the white part here. So using the white part and this alpha channel information from this alpha channel, I'm going to get something like this. So this image will have the background of the original image and the foreground of the image which I needed to overlay it with. So this way I get something like this. And once I've gotten this, so this is where this is happening here. So this is this. Once I run this piece of line, I'll get this. And once I have this, I will replace this original part of ROI with this new modified part. So this modified part is right now here, and all I'm doing here is replacing here. So this is where the replacement is taking place. As you can see, I'm modifying the exact part with the new updated ROI, which is this. And finally, once I've done that, I'll get something like this. And so this is what's happening here. The reason I showed you these examples was to make the whole process clear, because I know when I was initially learning these things early on in my career, it was a lot confusing. So this is why I made these illustrations to make this whole step clearer. So once we're done with this, all we need to do is display the results or return the actual image. And I'm gonna just initialize this function now, and then now we're gonna test this image on a video. And this is the code for the video. I'm setting up, initializing the camera. I'm making sure the camera is open. I'm reading the camera, making sure the frame is rect correctly. I'm laterally flipping it so I see a mirror image, and I'm calling the detect hand landmarks function. So once I get the results, I'm gonna check if the hands were detected, and if it is, I'm gonna call the count fingers function, the function that we just created above. And this function is gonna return to you the total number of fingers, is gonna return to you the updated dictionary, which is gonna tell you which finger is actually up and not, depending upon the true and false status. And this is gonna return, give you the updated original frame. And then what you're gonna do is pass these things inside another function called annotate. So this is this function which we just went over. So this function will overlay those individual finger images on top of the video. So here we're passing it the frame, the results, the finger statuses, and the total count, and we're going to turn off the display because we're working with the video. And now we're going to get the updated frame, which is going to be what you're going to be seeing with cv2.im show. And if someone presses the escape key, you're going to get out of the screen, and you're going to release the camera and destroy the windows. So now let's run this. Let me just change this to 1. So as you can see, these are the results for this. And if you're getting false positives, so here is this, 1, 2, 3, 4, 5, this. So this is working pretty accurately and fine. So this gives you, allows you to create a number of hand gestures. So with my 10 fingers, so I can create a lot of unique gestures and do a lot of things depending upon what gestures I'm making. So now we're all set to create a full-fledged gesture recognition based application. So if you're getting something like this, a few false positives here and there, you can increase the confidence of the tracking and the detection module, and this will get rid of these false positives. Alright, now let's close this up. So in this step, what we're going to do is recognize different hand gestures, and it's actually really simple because the bulk of the things that were to be done is already completed. And all we need to do is put up simple if conditions and check to make sure if 2 or 3 particular target fingers are up or not. So that's it. So all we're doing here is first I'm just creating a dictionary to store the gesture status of my left hand and my right hand. And so initially this dictionary will have unknown as hand gestures because we haven't detected any gestures. And then what I'm going to do is just check if my middle finger and my index finger are up, and if they are and the total number of fingers are 2, then this means, you know, like I'm putting up a V sign. So this is a V sign. So if both my fingers are up and total number of fingers are 2, so this is a simple single line of code, and in this single line of code I've just created one gesture recognition program. So and all I need to do is just update the hand gesture dictionary to a V sign. And I'm just changing the color as green, so this is just for displaying purposes. Anyways, so this is for just one gesture, and if I needed to detect some other gesture, all I need to do is just change this if condition. So here what I'm doing is checking to make sure if 3 fingers are up, and my thumb is up, my index is up, and the last finger is the pinky finger, I think, or the Spider-Man. So yeah, and my pinky finger is up. So if 3 of these fingers are up and the total number of fingers are 3, then this means I'm making this particular sign. And as you can see, the whole gesture recognition right now, because of the work we already done, because of the whole application, is really simple. We're just creating new gestures by one single line of code. So once that gesture is detected, we will update the dictionary with this new gesture, and then the last gesture. So for the last gesture, all we are doing is just making sure all 5 fingers are up, and if that is the case, all 5 fingers are up, then we have a high 5 sign. So we're updating the dictionary here. So and we're just going to draw the results and we're going to display it. So this is how this works, and let me show you the results here. So I'm showing you the results on random images. So for this image, the right hand is making the Spider-Man sign, and the left hand is not making any sign or it's unknown. So let's check it out another image. For this image, we have a right hand making a V sign, and the left hand is making an unknown gesture because this is not any stored gesture here. Anyways, for the last image, and we have this image, and the man's right hand is making this 5 high five sign, and the left hand is nowhere to be seen. Anyways, so this is how this whole gesture recognition works. Now what we're going to do, in the final step, we're going to create a hand gesture recognition system that do a couple of things depending upon which gestures are being raised or being made on the screen. And this is the best part of this entire tutorial. Anyways, and the code for that again is really simple. So all we're doing, the new thing that is happening here is we're just checking which gesture is being made. So remember, with this function which we just created, we also were returning the hand gestures. So we already know which gestures are being made on the screen in real time. So all we need is an if condition which checks which gesture is up. So if the hand gesture is equal to Spider-Man sign, then I'm turning the filter on. I'm setting the filter to true. And if the hand gesture is making a high five sign, then I'm setting the filter off. And finally, the third one, if we're making a V sign. So yeah, so if we're making a V sign, then what we're doing is we're saving the image. So we're taking a screenshot of the image, and we're optionally adding a border here, and also optionally using the Pygame library to play a click sound. So it's more realistic. So this is just optional stuff that you can do, and this makes it more cool. So this is some just optional stuff. All you need to do with the V sign is just cv2.imrad. But we're doing a bunch of other things, making a border around the image, playing a sound, so it's more cooler that way. Anyways, once you're done that, we're also displaying the results when you destroy the windows. So that's what's happening here. And there's a bunch of other things that I was also doing. So for each particular gesture, what I'm doing is making sure that that gesture is being made for set number of frames. And this is just to ignore some false positives. So here what I'm checking is the Spider-Man sign is up for n particular frames. And for example, if I didn't do that, then there will be false positives and the filter will turn on by default. So to just stop that from happening, I'm just making sure that my hand sign is up for some number of frames. And similarly, for each particular sign, for a high five sign, I'm doing the same thing, and for the V sign, I'm also doing the same thing. So the number of frames right now, which I've set it to, is 10. So this is the number of frames right now is 10. You can increase or decrease depending upon how smooth the results you want. Anyways, 10 is fine. So number of frames is 10. So if I put up the hand sign like this for 10 consecutive frames, only then the filter will be turned on and turned off respectively. You can decrease this number to make the filters turn on and off faster. So this is how this whole application is structured. Like I said, this is the only thing that is new here. The rest of the thing is pretty much the same which we were doing it previously. One other thing I will say is that I'm also resizing the filter to fit the screen. Otherwise, it will give you an error because if there's a mismatch. Anyways, that is new here, and now let's see the results. So this is me. As you can see, if I need to turn on the filter, I will do this, and the filter will probably turns on and turns off, turns on and turns off. And if I need to take a picture, I'll do this, and this will take a picture and turn on the filter and take a picture again. So this is how this whole application works, and let's close this up. So this whole tutorial comes with a neatly documented Jupyter notebook that can be downloaded from the link in the description. It also has a blog post. If you enjoyed this tutorial, please do let me know in the comments and like this video. By the way, in a few weeks I'm launching a really advanced computer vision course. Link to join will be in the description below. And I'll see you in the next video. Bye.